One application problem is using the Pythagorean theorem. The Pythagorean theorem was named off of the Greek mathematician Pythagoras, who lived in the 6th century BC. Most likely he is not the one who came up with the Pythagorean theorem, but all of his followers and his followers' followers gave him all the credit. Not like in today's world where we give ourselves the credit. Here they always gave their teachers the credit. I know this because he taught me. Idea. The Pythagorean theorem is used only for right triangles. And it shows the relationship among the three sides of a right triangle. So it relates the three sides of the triangle. Now, what is a right triangle? Well, a right triangle is a triangle that has a right angle. What's a right angle? A right angle is a 90-degree angle. It's indicated by having a little square in it. That is a right angle. A right angle is a 90-degree angle. So we have three sides of this triangle. Two of the sides, the two sides that form the right angle, are called legs. Once again, the legs are the sides that form the right triangles. We don't really care which one is which, because of our formula it will not matter. The key is to know that the longest side, which is also the side always across from the 90-degree angle, that is called the hypotenuse. The hypotenuse. That is always the longest side. Always the side across from the right angle. Now, for our theorem, the Pythagorean theorem, there's a nice little formula to it. We simply call the legs A and B. Once again, it does not matter which one you call A and which one you call B. The key is that the hypotenuse is always side C. And what was discovered was that if you squared this side, which was essentially creating a square off of here, and if you squared this side, which essentially, once again, was making a square off of here, and you added those two together, every single time you had a right triangle, it equaled the C value if you made a square off of there. So simply put, without all that scary picture stuff, we simply say A squared plus B squared will equal C squared. That's why it does not matter which one's A and B, because you'll square them and then add. And remember, the order of addition does not matter. So this is Pythagorean's theorem. A squared plus B squared equals C squared. Now let's come up with a couple of examples. All right, say we have this triangle with one side on the left of 4 and the bottom is a 3, and then we have x, or unknown, for our other side. First thing we need to make sure that we do is identify the sides. What are we looking for? Do we have an A? Do we have a B? Do we have C? What was the difference again? A and B are going to be legs. The legs are the two perpendicular lines, the two lines that form the right angle. C is always the side furthest or across from the right angle and not touching it. So the hypotenuse is over here. So that's what we're solving for. That's what we don't know. In our formula of A squared plus B squared is equal to C squared, the hypotenuse is always C. So we don't know C. Does not matter what we apply, which we say is A or B for our legs. I'll just go in that direction. Now we replace the A. A is 4. Now the formula says to square that, so I have to put a square on that. Then we add, b is 3, and there's a square on that. And then that's going to be equal to, well, since I wrote an x over here, we'll replace the c with x. But that x, remember, is still squared. That's still part of the formula. So now we simplify this side. Well, in order to simplify, we do our order of operations. Please excuse my dear Aunt Sally, which says I have exponents first. The square, once again, tells me that I have two 4's that are being multiplied together. So 4 times 4 is 16. Remember, we never take a big number times a little number. That's bad. Then we go plus 3 times itself is 9, and that's going to equal x squared. Continuing on, we now just do our addition, so we have 25 is equal to x squared. Remember, when you're adding by 9, you can always add 10 and then take 1 away. So 16 plus 10 is 26, then take 1 away, and you get 25. Right? Well, that's all fine and dandy, but we're not done yet. 25 is what x squared is equal to. I don't want to know what x squared is, I want to know what x is. Now, remember, whenever we do anything in math land with an equation, we can't just move something from this side over to that side. We have to do the inverse operation, the operation that will cancel this. So some number squared is 25. Well, to cancel out a square, we square root. Whoops. If I square root one side, I have to square root the other side. So the square and the square root cancel on this side, leaving me with just my my base number of x. And on the other side, we say, well, what number times itself is 25? And we get 5. So my answer is x equals 5. That happens to be one of the special triangles. It's called the 3, 4, 5 triangle. It's the only one that has consecutive numbers like that complete the Pythagorean theorem. Hold it true. Construction workers use that a lot to make sure that they can form right angles. The ancient Egyptians, it shows that they used the 3, 4, 5 triangle. You measure three of any distance that you have, one direction, 4 the other, and when the corners match up to be 5, then you know you have a right triangle. And that's how they formed the pyramids, with perfect squares, a perfect 90-degree angle at all the corners on the base of the pyramids. They used Pythagorean's theorem, and the pyramids were built 2,000 years before our so-called Christ, BC. So 4,000 years ago. Kind of interesting. Let's do one more. Here I have one of my legs, and I don't know the other leg, but I do know that the hypotenuse is the square root of 3. Oh boy. So once again, if you need to identify it on your sheet, draw it all out. I know that a will be x, b will be 1, c will be the square root of 3. And now we plug it into our formula. Whenever we're using a formula, the proper thing is to write the formula down so that you don't make any little boo-boos. A we don't know, we called it x, so I'll replace it with x. B is 1, so I'm going to square that. And c is the square root of 3. All right, and we'll square that. Now we're still going to solve through, and in order to solve, we have to get rid of those squares. That's still going to be our first step. Can't do anything with an x squared. 1 squared, be careful here. 1 times itself a gazillion times is still 1. What happens when I square the square root of 3? Well, a square and a square root are inverse operations. They cancel each other, so I'm left with just the 3. Oh, that's not so bad. Now we solve. In order to solve, I have to get the variable by itself, so I'm subtracting 1. But I don't want to know what x squared is, I want to know what x is. So to cancel out a square, we take the square root. So x is equal to the square root of 2. Now, depending on what your directions state, you might want that as your answer. But if this says that you want to round, then you need to plug it into your calculator. And if you round it, probably round to the nearest hundredth, you get 1.414. Okay. If you're having issues with rounding, remember that I do believe it's page 23. Page 23 reviews rounding. Some of us are still getting that wrong. So go review rounding on page 23. So Pythagorean theorem is a nice way of finding the sides of a right triangle. It has nothing to do with angle measurements. It's nothing to do with the slope. It's finding the sides of right triangles and only of right triangles. Great application that you might use in your life. Good luck.